tutorial we will be discussing significant figures. Significant figures is a way of writing numbers to reflect precision. For instance, we compare pennies versus gold. Pennies come in whole numbers, and a count of 7 pennies means that there's 7 whole pennies. However, our knowledge of the amount of gold in a 10-gram bar depends on how precisely it was measured. So scientific numbers are reported so that every digit is certain except the very last one, which is estimated. So in here, the first 4 numbers, the 45.87, are certain. We know for a fact that it's at least 45.87. The last digit at the end, however, is estimated, and I'll show you some examples of this in a second. The greater the precision of the measurement, the greater number of significant figures. So let's take a look at this scale. The markings on this scale here are in 1 grams. So, when estimated to because it's in 1 grams, we want to estimate out 1 digit past that, which would then be the 10th place. To do this, you look between them. So here's the marking here of where the scale is lying. It's past the 1, but not quite towards the 2. They've estimated it to be 1.2 grams. Here's one that has it to the hundredths gram. You'll notice here's the 1, here's 2, and there's 10 notches between them. So there's counting by ones for the big numbers, and there's 10 notches. So that means it's 1/10. So each one of these markings here means 1/10. You count the numbers of notches, and that's when that reflects those 10th place. Then you're going to estimate between the 2 notches that it's falling between, and that's how you get it to the hundredths place. So you count, and then you estimate the last one. So let's take a look at this one. This is a bathroom scale. Here's our reading. First thing you have to do is take a minute to look at what the measurements are telling you. Here's 140, here's 160. There's a long line here separating it. So therefore that's 150. So it's going from 140 to 150, that's 10 counts. And there's 10 notches between them. So that means each one of those notches are worth 1. So that means 141, 142, 143, so on and so forth are the notches. Now I've actually written over what it says, but I can tell that it's 145 for that long notch there. It's going 2 more past that, so 45, 46, 47, and then it's somewhere between 147 and 148. So I'm going to estimate it as 147.5. I went out to the 10th place because I want to go between, I want to estimate between the notches. Here's another one. 90, 100, 110, 120. So that means I'm going from 100 to 110. I'm going by, I have a difference of 10 for here. Now I'm looking at the gradients. I have 10 gradients here. So that means that each one of these gradients, each one of the notches, are worth 1. So that means 100, 101, 102, 103. So I know it's at least 103. Now I'm going to estimate between 103 and 104. And it looks like it's about a third of the way up. So I'm going to say 103.3. Alright, so now that we know how to measure, let's talk about how to determine the number of significant figures that are in a number that's already been determined. All non-zero numbers are significant. So anything 1 through 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, any of those numbers are all significant. Interior zeros are the zeros between numbers. So 1, 1, 0, 1. That 0 is significant. These 3 are the rules you're really going to get stumped with. Trailing zeros and leading zeros. Trailing zeros are the zeros to the right of the numbers. So we're talking about 1, 2, 8, 3, 0, 0, 0, 0. These are trailing zeros. If you see a decimal point there, like if I had a decimal point right here, all of those zeros are significant. If I do not have a decimal point there, those zeros are not significant. I would have 1, 2, 3, 4, 5, 6, 7, 8 significant figures there because of the decimal. Whereas down here, I only have 4 because there is no decimal. So when you're looking at trailing zeros, you want to look for the decimal. Leading zeros are never significant. Alright, so the zeros leading up to a number are never significant. Both leading zeros and trailing without a decimal are considered to be placeholders. They're moving the number frontward or backwards, therefore making the number bigger or smaller. It's not actually having any effect on the actual measurement. Alright, so exact numbers. Exact numbers have an unlimited number of significant figures. And this is what we were talking about when we were talking about the pennies, where we said we had 7 whole pennies. It could be 7, it could be 7.00, 7.000000. It could have an infinite amount. It doesn't matter. It's still going to be 7. So exact counting of discrete objects is going to be in unlimited number of significant figures. Integral numbers in a part of an equation are infinite. You don't have to worry about those. Defined quantities, like 1 meter is equal to 100 centimeters. That's defined. It could be 100, it could be 100.0000. It doesn't matter. Some conversion factors are defined quantities while others are not. And we will go into that as we get further on into the semester. So let's take a look at these and figure out which ones are significant and which ones are not. These here are leading zeros. They are not significant. So the 3 and the 5 are the only two that are significant. 1.080. This is a trailing zero, but there's a decimal here. Because of that decimal, that makes that number significant. So that means I have 4. Here, they're all non-zeros, so all of those are significant. In scientific notation, you look at the numbers at the start. So there's 2 here. 1 dozen is equal to 12. Well, that's a definition. So that's unlimited, that's infinite. And here we have, once again, we have a decimal. So that means the trailing zeros all count. So 1, 2, 3, 4, 5. Now I'm going to throw one more tricky one out for you. How many significant figures are here? Well, these are leading zeros, so those don't count. We also have trailing zeros here. Because of this decimal right here, those are significant. So that means there's 1, 2, 3, 4 significant figures here all together. And that's how you determine significant digits.